All right, this series of videos will be a review of basic statistics from a unit of Algebra 2, high school statistics. The first few questions involve sampling methods. So these are the 6 sampling methods that we have learned about. I'm just going to go through them real quick in like 1 minute. So convenience is where you just pick one group that you have easy access to survey or measure or whatever. So if I just walk into a room and say, hey, let me survey you guys, that would be convenience. Now, voluntary response is also known as self-selected, and that's where the people that participate in your survey or the people that get measured in some way choose themselves to participate. So some common ways that will happen will be if there is a survey that's posted on a website, for example, or if you send out a survey in the mail, that's going to be automatically voluntary because people could just throw it away. Or if you just leave your survey on a table. And people can walk up and take your survey if they want to. Those are examples of voluntary response. Simple random is where, similar to convenience, you just have one group, but in simple random, you take the entire population as one big group, and then you use a computer or some other purely random system to pick your participants. Okay, so if you're choosing randomly from your entire population, that's going to be simple random. Now, stratified random is where you divide your population into groups, and then you choose some from each group. So that could be done either, imagine rooms, so I'm in a high school, so there are several classrooms in this high school. If I randomly pick 3 students from each class to participate in my survey, that would be stratified random. On the other hand, you could do it by types of people. So we have freshmen, sophomores, juniors, and seniors. So if I pick 20 freshmen, 20 sophomores, 20 juniors, and 20 seniors randomly, but I pick 20 of each kind, then that would also be stratified random. So if you pick some from each group, that's stratified random. Now, cluster is where you randomly choose whole groups at a time. So back to my classroom example, if I randomly picked 5 classrooms to survey, but if you're in one of those 5 classrooms, then I automatically survey everyone in the classrooms that I choose. But I'm randomly choosing entire classrooms, so that would be cluster. And systematic is where you have some type of a system, like you're picking every 5th person off of a list, or you're picking every 8th person that walks in the door, or you're choosing every other person in the line. So these are the 6 methods that we've talked about. Okay, now these first 2 sampling methods usually have something called bias. Now in statistics, bias means that your sample is not going to represent your entire population very well. There's not going to be a good match between whatever you measure from your sample as opposed to that same quality for your entire population. So convenience, for example, will give me a biased sample very often because imagine that you wanted to know the average height of a student in a high school. So you walk into a classroom and just measure everyone's height in that classroom. And you figure the average height in that classroom should be pretty close to the average height of the whole school, so you use that to represent the school. So that's convenience because I just walked into one group that I had easy access to. I didn't do any of these other things. But the reason why that is likely to be biased is because if you walk into one classroom, there's likely to be one level of student, one grade. So if you walk into a senior classroom, those students are going to be relatively tall compared to the general population. So the average height in there is going to be too high. It'll be above average of the whole school. So that's biased because your sample doesn't match the population. If you happen to walk into a freshman classroom, the average height in there is going to be relatively short compared to the whole school. So that would be, that sample would be biased in the direction of being too short. Again, bias just means your sample measurement does not well represent the entire population. Okay, so in general, I could say convenience sample will often be biased because your one group will often have too much in common. Like they're all freshmen, so that makes them too short, or they're all seniors, so that overall that's going to, in general, make them too tall, that type of thing. Now, voluntary response is often biased for a different reason. So imagine that you are trying to decide, you are the superintendent of schools, and the budget is really tight. Something's got to be cut. So you're thinking about cutting, let's say, the art department. Okay, we're going to focus on math, literature, science. Art has to go. We can't afford art. But first, you're going to send out a survey to the parents in your district and see what they think about that. Well, the thing is, if it's voluntary response, say you mail it out, you're going to get far more responses from people that are directly affected by what you're planning to do. So if you're planning on cutting the art department, anyone who is affected by that, the artists or parents of artists, they are going to definitely fill out that survey and say, no, don't cut the art department. Art is so important. On the other hand, the people that, they don't really care one way or the other. They have no artistic talent. They don't know anybody with artistic talent. They just don't really care. Well, because they don't really care, they're probably just going to throw that survey in the trash and not take it at all. So you're going to get a voluntary response bias where your sample is going to have many, many people who feel strongly or are passionate in one direction or the other. So again, voluntary response is biased because you'll get more responses from people who are passionate about the issue, people that are directly affected. Okay, that was a quick review. Okay, a little bit longer than the minute that I said I was going to be able to do it in. I think that was a little ambitious of me. But let's go ahead and get started on these questions. Which of the following is not a sampling method? Well, we just went through the 6 sampling methods that we've learned about. And let's see, the one that's not there is this one. There's no such thing as a block sampling method. So the answer to number 1 is B. Now, looking at number 2, which of the following is or are true statements? Let's see, voluntary response samples often have relatively few people with strong opinions. Okay, is that true? Well, that's the opposite of what I just said a minute ago. Voluntary response samples, you're going to have more responses from people who are passionate about the issue, people who have strong opinions. All right? So this is the opposite of what's true. All right? You're going to have few people with strong opinions? No. You're going to have many. You're going to have more people with strong opinions. So number 1 is false, so that's not going to be included for sure. Okay, now number 2, as the size of a sample increases, the margin of error decreases. Well, okay, you know what? We didn't really talk about that yet. Okay, this is the formula for simple margin of error. It's 1 over the square root of n, where n is the sample size. Now let's see what happens as the sample size increases. Margin of error. Let's say if the sample size was 4, all right, 4 people in the survey or whatever, then the margin of error would be 1/2, which is the same thing as 0.5, which is the same thing as 50%. What if, let's increase this, margin of error. What if the sample size was 9, okay, making it bigger? That would be 1/3. That would be 0.333, which is the same as 33.3%. Let's see, can I move this over a little? Yeah. Okay, let's go one more. Margin of error. What if the sample size was 16? All right, then that would make this 1/4. That's 0.25, which is the same thing as 25%. So the margin of error, as the sample size increased from 4 to 9 to 16, the margin of error went from 50% to 33.3% to 25%. So as the sample size increased, the margin of error decreased. So as the sample size increases, the margin of error decreases. That's exactly what we just saw. So number 2 is definitely true. So what about number 3? Questionnaires with neutral wording are likely to have response bias. In this context, bias means influencing a person in one direction or another. So if I ask you a survey question and I say, do you agree or disagree with this ridiculous proposal? Then by calling it a ridiculous proposal, I've introduced bias into the question, and I'm making you want to not say yes, not say agree. But if I use neutral wording, where I say, do you agree or disagree with this proposal? You know, I'm leaving out the word ridiculous. That's the biasing word. The neutral wording will not be biased because I'm not saying ridiculous or stupid idea or something like that. So questions with neutral wording are not likely to have response bias. So this is false. So only 2 is correct. This is wrong. So the correct answer should have been D. For number 3, I'm going to skip to the end and see what they're asking me for. That way I can point it out as we go. So in the end, they're asking, what is the explanatory variable in this study? So what does that mean, explanatory variable? Well, you've probably talked about cause and effect. Cause and effect. All right, if it rains, then we are wet. Okay, rain is the cause and being wet is the result. So keep that in your mind. In the context of variables in an experiment, the potential cause is called the explanatory variable. So you have your explanatory variable. And the result, if we find any, will be the response variable. So we have explanatory variable and the response variable. All right, is analogous to cause and effect. So if you're trying to study the effect that a new drug will have on headaches, so in that case, the new drug would be the explanatory variable. And the number of headaches would be the response variable. Okay, so that's what we're looking for in this problem. So they're asking us for the explanatory variable. So it's the cause, not the result. You know, so it'll be the treatment. Whatever turns out to be the treatment, that'll be the explanatory variable. Anyway, so now let's read the problem. A graduate student conducts a survey to determine whether a new activity-based method, okay, so we've got a new activity-based method, is better than the traditional lecture. Okay, so that's what they're studying. He found a teacher, Professor Perky, who agreed to try the new activity-based method in 2 classes and the traditional lectures in the other 2 classes for an entire semester. Each of the classes has approximately 40 students for adequate replication. Okay, that means repetition. At the end of the semester, all of the students will take the same final exam, and then their scores will be compared. So we've got the final exam scores are one of the variables, and you know, whichever learning method was used, all right, that's the other variable. All right, so the learning method and the final exam score. So learning method, and we're trying to see how that will affect their final exam scores. Okay, so the learning method would be sort of like the cause, and the final exam score would be sort of like the effect, you know, the result. So we said that so they're asking us for the explanatory variable, so they're asking us for the cause, you know, this side of the equation. Okay, so that means the learning method is the explanatory variable. So for that reason, the answer should have been D. Okay, the final exam score would be the response variable, by the way. All right, number 4. Okay, so they're asking us which sampling method this is. So just keep in mind our sampling methods I spoke about a minute ago, okay, and sort of what they each mean. So a committee on community relations in a college town plans to survey local businesses about the importance of students as customers. From telephone book listings, the committee chooses 150 businesses. Of these, 73 return the questionnaire mailed by the committee. The 73 returned questionnaires are used. What sampling method was used for the survey? Well, earlier I mentioned that if you post a survey on a website, or if you mail out the surveys, or if you put your surveys out on a table for people to take when they walk by if they want to, all of these are examples of voluntary response. So mailing out the surveys is automatically going to be voluntary response because people can just throw them away if they want, and they usually do. So the correct answer was E for that one. All right, in a double-blind medical experiment, okay, before I even look at the answer, all right, let me not see the answer yet. The 2 blinds in double-blind are the following. When we say double-blind, okay, a double-blind experiment, the first blind is that the subjects don't know which treatment they got. So if there's a drug that's being tested and a placebo, which is like a fake pill that doesn't do anything, the participants in the experiment, the subjects, don't know if they've got the real drug or the placebo. So the subjects don't know. I forgot the K. The subjects don't know which treatment they got. Okay, And if it's a double-blind experiment, the second blind is that the person conducting the experiment also doesn't know which treatment any given subject got. All right, so there you go. The person performing the experiment doesn't know which subjects got which treatment. So students often will ask me, well, it sounds like nobody knows, so how will they interpret the results? Well, no, there's another person, a third party, who set up the experiment, and then they passed it over to a colleague and kept secret, which groups are going to get the placebo. But there's someone else, a third party, knows which group is getting which treatment, but the person who's actually performing the experiment doesn't know. By the way, the reason for that is to avoid another kind of bias. Now, it's not that we don't trust the scientists that are conducting the experiment, but if you know that a person is getting a pill that's supposed to make them feel better, and so you're asking them the question, if your poker face isn't very good, you can accidentally give the person hints just in your tone of voice, facial expressions, so when you're asking them, well, how do you feel today? You're expecting them to feel better. They might hear in your voice that you're expecting them to feel better. You sound chipper when you ask the question. You might even accidentally nod a little bit, if that's one of your tells, that we would call it in poker. Are you feeling better today? And then you're nodding at them subconsciously because you're expecting them to feel better. And then they say yes because they see you nodding. You know what? I think I do feel better. So that's a bias. So it's better if the person performing the experiment doesn't know whether or not you got the real medicine, so they don't subconsciously give you clues and cues about how you should be feeling. Anyway, that was a long explanation for this very short problem. So double blind. All right, the patient doesn't know the treatment. Wait, the patient knows. No, so we just said the patient does not know. So the answer is not A. The number of subjects and treatments is unknown. The number of subjects and treatments has nothing to do with it. The doctor knows the treatment, but the patient does not. Nope, the doctor does not know either, so that's not it. Both know the treatment and both are blind. Nope, it's not about people being blind. All right, so the answer must be E. A higher person knows the treatment, but neither the doctor nor the patient knows the treatment. Yep, that's what we were just talking about. So the answer is clearly E. Okay, and finally, standard deviation. We'll go into more detail on this later, but standard deviation or z-score, if you say somebody has a z-score of 2, it means whatever value we're talking about, if their height has a z-score of 2, it means their height is 2 standard deviations above the mean. So if you make a chart, a z-score distribution, okay, we'll put a line right down the middle. Now the mean is always going to be 0 for z-score because a positive z-score means you're above average, a negative z-score means you're below average, so the mean is always going to be 0 if it's a z-score distribution. But now as we go up, okay, if you have a z-score of 2, that means you are 2 standard deviations above the mean. So if you have a z-score of 1, that means your score is 1 standard deviation above the mean. So that means that the standard deviation for a z-score chart is going to be 1. Because each one of these lines I'm drawing is a standard deviation, and here we have it, it's going up by 1, 2, 3, etc. And this would be -1, -2, -3. So z-score is automatically, we've made it so that the standard deviation is 1. Okay, so that's what we're looking for. Mean of 0, standard deviation of 1, because it's like 1, 2, 3. So let's see, mean of 0, standard deviation of 1. All right, well, there it is. The answer number 6 should be A.